Assalamualaikum. Hi everyone. So this is a video for chapter 7 Haloalkanes. In this video, we're going to discuss on subtopic 7.2 chemical properties of haloalkanes, and at the end of this lesson you should be able to explain SN1 and SN2 mechanisms and show SN1 and SN2 mechanism of a given haloalkane. So now let's start. So firstly, we're going to recap a bit about our haloalkane. Okay, we're going to focus on the nucleophilic substitution reaction of haloalkanes. So, this is the reaction for nucleophilic substitution reaction, where we have our haloalkane reacts with the nucleophile. So, the nucleophile will be substituting our halogen, okay, our X over here, which will be the leaving group, and this is the product of the substitution reaction. So our nucleophile, we have two types of nucleophile. We have strong nucleophile and we have weak nucleophile. So please make sure that you remember, okay, how to determine the strong nucleophile and how to determine the weak nucleophile. Okay, now, so let's proceed. So we're going to look on the SN1 and SN2 mechanism. But before we look on the mechanism itself, so let's discuss a bit about what is SN1 and what is SN2. So SN1 and SN2 mechanism. So the first one, SN1, stands for unimolecular nucleophilic substitution. So the S over here stands for substitution, and nucleophilic, one, unimolecular, meaning it will involve one molecule. Okay, and then the second one, SN2, is bimolecular nucleophilic substitution reaction. Again, the S is substitution, N is nucleophilic, and 2 is bimolecular. Okay, why do we have unimolecular and bimolecular? Which molecule are we referring? So, the unimolecular and the bimolecular, it refers to the slow step, the rate determining step for the mechanism. Okay, so now let's look at it one by one. Okay, we're going to start first with the SN2 mechanism. Okay, why do we call it as SN2 mechanism again? So yang pertama, it's a bimolecular nucleophilic substitution. Okay, I keep on mentioning bimolecular. Apa sebenarnya yang bimolecular? So the reaction will involve two molecule, which is the haloalkane and nucleophile. Okay, yang ni adalah spesifik pada rate determining step. Okay, all the reactions untuk nucleophilic substitution, okay, kita akan ada haloalkane, kita akan ada nucleophile, but the rate determining step will determine the type of reaction. Okay, rate determining step is usually the slow step. Okay, jadi if the slow step involve haloalkane and nucleophile, so dia adalah SN2. So nanti untuk SN1 kita akan tengok apa beza dia. So the second one, we call it as SN2 mechanism because it is a second order kinetics. So second order reaction. So ini akan melibatkan awak punya chapter kinetics. Okay, so yang mana we have over here our rate law, okay, or rate equation. So rate equals to K times concentration of your haloalkane and concentration of the nucleophile. So in other words, these two species, our haloalkane and our nucleophile, okay, dua species ni akan mempengaruhi rate of reaction. Okay, so dekat sini Rx is our haloalkane nucleophile, Nu is our nucleophile. So it's either the strong nucleophile or the weak nucleophile. It doesn't matter. Okay, and then so example over here. Okay, so I have a reaction CH3Cl plus OH minus. So hydroxide ion is a negative ion over here. So you will have over here your strong nucleophile. Okay, so bila soalan, sometimes the question can ask you to write down the rate of reaction. Okay, jadi kalau dia adalah SN2 mechanism, rate of reaction akan ditulis sebagai rate equals to K times concentration of CH3Cl times concentration of OH minus. Okay, so dua ni lah. Sebab apa? It's a second order reaction. So the rate of reaction will depends on the concentration of the haloalkanes and the concentration of the nucleophile. Okay, so like I mentioned before, okay, and then it is a second order overall reaction. So this SN2 mechanism is a one-step mechanism. Okay, apa maksud dia one-step mechanism dekat sini? So when you are writing down the reaction, okay, you will write it down as one reaction. Kita tak akan letak step 1, step 2, step 3. Okay, it will be a continuous reaction. Okay, yang mana dekat sini, the one-step mechanism, it will have a transition state and there will be no carbocation rearrangement. Okay, so kita punya gambar as it is. Okay, cuma dekat sini, bila kita buat SN2 mechanism, you need to draw your structure in a 3D structure. Okay, so 3D structure, kita kena lukis dalam bentuk tetrahedral. Okay, so this is an outline of our one-step mechanism. Okay, kalau nampak dekat sini, satu step mechanism sahaja, tak ada step 1, tak ada step 2, it's continuous. Okay, now reaction akan start dekat mana? So first, we have over here a partially negative and partially positive. Partially positive pada carbon, partially negative pada halogen. Okay, jadi apa yang kita nak tentukan dekat sini sebenarnya? So when we have a partially negative and partially positive, so dekat sini adalah electrophilic site. Okay, pada awak punya carbon. So nucleophile, dia adalah nucleophile lah. Okay, so sebab tu reaction akan start sentiasa dengan nucleophile attack electrophile. So that's why the first arrow is from nucleophile towards the carbocation dekat sini. Okay, so once the nucleophile attack the carbocation, okay, this is the haloalkane. Okay, so the belum jadi carbocation lagi. So attack the partially positive carbon. Okay, itu yang saya maksudkan sebenarnya. So this carbon hydrogen bond will break. Okay, dengan dua elektron akan pergi kepada X. Okay, tetapi dekat sini kita takkan terus break kan. Okay, sebab apa? Usually SN2 mechanism, okay, yang ni kita akan buat untuk primary haloalkane. Okay, so still remember what I said about primary carbocation. Okay, masa kita belajar benzene. So I told you that if we have a primary carbocation, it is unlikely to be produced. Okay, primary carbocation takkan terhasil. Sebab apa? It is very unstable. So that's why dekat sini untuk SN2 mechanism, okay, usually adalah untuk primary haloalkane yang akan hasilkan primary carbocation. Kita akan ada dekat sini kita punya what we call this as the transition state. Okay, so transition state dekat sini. Okay, so this step nucleophile attack kita punya partially positive carbon and then this bond akan start break. Okay, so dua molekul yang terlibat dalam the first step, the slow step. So kita akan labelkan dia sebagai slow step dekat sini. Okay, so produk dia dekat sini adalah kita akan dapat transition state. Okay, so this is the transition state. So untuk lukis transition state dekat sini, okay, so if you look over here, okay, initially awak akan lukis awak punya carbocation, the carbon bonded to the halogen. Okay, macam ni. So you going to draw it as a 3D structure. Okay, and then 1, 2, 3. Okay, so once the nucleophile attack the carbon, so nucleophile akan start form bond dengan carbon. Carbon akan start break dengan halogen pada transition state. So at this transition state, dua-dua bond ni belum fully terbentuk, belum fully putus. Okay, it's in between. So that's why we have a transition state over here. And if you look over here, bond yang solid line ni dia jadi straight, and then these two wedge and dash, okay, kita jadikan dia macam ni. Okay, you're going to draw it split like this. Okay, and then from the transition state to the product and the leaving group. So this is the leaving group, yang mana this carbon halogen bond will break, you will have your leaving group, and finally the carbon and the nucleophile bond will be formed to produce the product. And this step we call it as the fast step. Okay, so macam saya mention tadi, okay, the slow step over here we call it as the rate determining step. So the whole step over here. Okay, dua ni nucleophile attack haloalkane, okay, attack the partially positive carbon, it will be a slow reaction. Okay, sebab tu rate of reaction ditentukan oleh nucleophile dan haloalkane. Okay, tapi from the transition state to the product, it's a fast reaction. Okay, jadi yang ni kita tak kira fast reaction ni, kita tak kira lah dalam kita punya order of reaction. Now let's look on example 1. Okay, so for example 1, okay, so here I have OH minus, okay, plus CH3Cl to produce CH3OH plus Cl minus. So again, this is SN2 mechanism. Okay, so like I mentioned before, SN2 mechanism dekat sini, okay, yang ni adalah untuk primary haloalkane. Okay, usually adalah untuk primary haloalkane. So, if you look over here, okay, kita ada dekat sini, kita punya nucleophile, okay, and then this is the haloalkane, this is the product, and then this is the leaving group. Okay, jadi macam mana kita nak start kita punya reaction? Okay, so your nucleophile over here, okay, and then you're going to draw your haloalkane. Okay, so like I mentioned before, haloalkane mesti dilukis dalam bentuk tetrahedral baring macam ni. Okay, so if I were to draw, okay, kalau saya nak tunjuk macam mana nak lukis, okay, so you're going to start, so let me just draw somewhere, okay, over here, so C, okay, Cl. So this one mesti solid line. Okay, jadi lagi satu solid line sama ada awak nak buat atas, okay, dekat atas sini boleh. If you want to do it up here, okay, boleh. Ataupun awak nak buat macam dalam gambar ni pun boleh juga, tak ada masalah. Okay, so if you do it up here, so yang lagi dua dekat bawah ni, okay, so satu, okay, and then dua, H dan H. So dia kena 3D structure dekat sini dah. Okay, kenapa perlu ada 3D structure? Because we want to draw 3D structure kat sini sebenarnya adalah untuk tunjukkan nucleophilic attack tu berlaku macam mana. Okay, so this is the haloalkane. Okay, carbon tadi partially positive, chlorine partially negative. So the hydroxyl group akan attack carbon. So this is what we call as the backside attack. Okay, ini. Okay, backside attack. Okay, sebab tu adalah sangat penting untuk kita lukis kita punya haloalkane dalam bentuk 3D structure dekat sini. So arrow ni dipatutnya akan betul-betul pergi dekat carbon. Okay, so when the nucleophile attack the carbon over here, okay, ikut backside attack, okay, so this bond will start to break. Okay, the oxygen carbon bond akan start to form, the carbon chlorine bond akan start to break. Okay, so the slow step, so awak mesti lukis arrow, lepas tu letak perkataan slow dekat sini, wajib ada. Okay, to show that this is the slow step, the rate determining step. Okay, and then you need to draw the structure like this. Okay, so maksudnya the carbon oxygen bond akan start terbentuk, so awak kena letak garis putus-putus kat sini lah. Okay, and then chlorine, carbon chlorine bond akan start break pun kita akan letak garis putus-putus. So, 2 bond dekat sini tadi, okay, kita tegakkan macam ni. So, if let's say you are using this one. Okay, jadi kalau awak gunakan yang ini, okay, so gambar dia akan jadi macam ni lah. Okay, so C. Okay, C dekat sini. Okay, so the hydrogen bond yang dekat sini ni. Okay, this one, kiranya this one. Okay, akan jadi tegaklah dekat sini. H. Okay, and then garis putus-putus H. H. So, dekat sini. Okay, ini kan macam ni. So, awak akan lukis garis putus-putus je macam ni. Okay, like this. Cl. OH. Okay, so it will be like that. Dan untuk menunjukkan yang dia adalah transition state, dia mesti ada bracket dekat sini. So you need to show the square bracket. So mesti lukis square bracket dan awak kena tunjukkan tanda ni. Okay, so meaning kalau dekat gambar yang saya lukis ni, okay, so you need to have your square bracket. Okay, and then mesti ada tanda transition state. Okay, so kalau nak lukis tanda transition state tu macam ni lah. 1, 2, 3. Okay, wajib ada. To show that you have over here a transition state. Okay, so transition state, chlorine awak labelkanlah dia sebagai partially positive. Oksigen dekat sini pun partially positive. So kiranya dekat sini on the transition state, the 2 bonds that to be formed yang nak dihasilkan dan yang nak putus, dua-dua adalah partially negative. Okay, so next one is the first step. Carbon chlorine bond akan break, so akan jadi leaving group, dan carbon oxygen bond akan form, so you will have your product. Okay, jadi bila kita nak lukis produk, so 2 bond yang dekat atas ni tadi dia akan tertolak ke sebelah kanan. So, jadi macam ni lah. Okay, and then yang carbon hydrogen bond ni pun akan tertolak juga ke sebelah kanan. Okay, so you will get another tetrahedral shape dekat sini. OH ni, letak OH biasa saja pun dah cukup. Okay, I mean you don't have to show the oxygen hydrogen bond dekat sini. Okay, just put as OH. But the carbon must be bonded to oxygen. So, the OH, the nucleophile, attacks the backside of electrophilic carbon. So, dekat sini tadi, electrophilic carbon atom, donating a pair of electron to form a new bond. So, backside attack dekat sini. Okay, now. Okay, all SN2 reactions proceed with backside attack, resulting in inversion of configuration at the electrophilic carbon atom. Okay, apa maksud inversion of configuration yang tadi lah? Okay, so let's say I have here my nucleophile, okay, and then my haloalkane over here, so partially positive carbon ataupun kita punya electrophilic carbon, because macam saya mention tadi, this is our electrophilic side. Okay, this is partially negative chlorine. Okay, so hydroxyl akan attack dari belakang. Okay, and then this bond will break. Okay, so last kali produk dia adalah macam ni. So initially the tetrahedral 1, 2, 3 dekat sebelah kiri. Okay, 1 kat sini sebelah kanan. Okay, but when we produce the product, okay, seolah-olah bond dia punya kedudukan dah inverted. Okay, macam nampak ada mirror image dekat sini. Cuma, it's not a mirror image. Why? Sebab dekat sini, leaving group. Dekat sini, nucleophile. Okay, seolah-olah macam mirror image. Tapi, dah berlaku substitution. So, this is what we call as inverted structure. Ataupun inverted configuration. Okay. So, okay, this is the leaving group just now. So, OH tadi adalah nucleophile. Dia dah form bond dengan carbon and the carbon chlorine bond akan break. Chloride ion akan leave sebagai leaving group lah. Okay, so kita ada inversion of configuration dekat sini. So, the nucleophile approach the side opposite 180 degree to the leaving group. So, ini bila kita mention tentang backside attack. Okay, dia hydroxyl group dia takkan attack daripada sini. Okay, dia tak akan attack daripada bawah ke sini ataupun dia tak akan attack dekat sini. But it will attack, kiranya align dekat sini 180 darjah. So back side attack lah. Okay, now, so let's look at the order of reactivity for SN2 mechanism. Okay, so here I have a general structure untuk haloalkane. So here is a tertiary haloalkane. Okay, secondary, primary and methyl halides. Okay, so susunan yang ada dekat sini adalah increasing rate of SN2 mechanism. Okay, so maksudnya dekat sini yang paling suka undergo SN2 mechanism adalah methyl halide. Okay, dekat sini our methyl halide and also our primary haloalkane. Ni yang paling senang. Okay, so saya boleh kata dua ni easiest to undergo SN2 mechanism. Okay, dan untuk tertiary dia unlikely to undergo SN2 mechanism. Okay, so selalunya macamlah kita boleh terus pangkah. Okay, tapi dekat sini dia ada dekat dalam reactivity. Sebab apa? Just nak tunjukkan. Okay, siapa yang paling senang untuk undergo SN2? Paling senang primary and methyl halides. Tertiary haloalkane confirm selalunya takkan undergo SN2 mechanism. Okay. Kenapa? Sebab the backside of the electrophilic carbon is hindered by the presence of bulky alkyl groups. Okay, so statement ni adalah merujuk kepada kenapa tertiary haloalkane cannot undergo SN2 mechanism. Okay, apa yang dimaksudkan dekat sini? Backside of electrophilic carbon hindered by presence of bulky alkyl group. Dekat sini. Okay, so first awak kena faham maksud perkataan bulky dekat sini adalah besar. Okay, so apa maksudnya dekat sini? So kita tengok slide yang seterusnya. Okay, so here, if you look over here, okay, primary haloalkane, so the carbon that is bonded to the halogen, to the leaving group, okay, dekat sini cuma ada satu sahaja alkyl group. Okay, so as the number of alkyl group increase, okay, jadi kita punya nucleophile, okay, so nucleophile tadi, okay, awak bayangkanlah ini adalah okay, so saya lukis dalam bentuk 3D structure tadi. Okay, so sini H, okay, okay, H, CH3. Okay, dengan yang dekat sini C, Cl, okay, CH3, CH3, CH3. Okay, so nucleophile dekat sini bila dia nak attack, okay, senang. Sebab apa dia senang nak attack kita punya primary haloalkane dekat sini? This is because primary haloalkane dekat sini, okay, ada satu sahaja alkyl group and these two nitrogen adalah small. Okay, jadi banyak ruang untuk nucleophile attack. Okay, tapi kalau untuk tertiary haloalkane, alkyl group, okay, ketiga-tiga dekat sini adalah alkyl group. So when you have an alkyl group, carbon itself is quite big. Okay, jadi bila dah tersusun banyak carbon kat sini, so nucleophile nak masuk ke belakang untuk lakukan backside attack adalah sangat susah. Okay, so that's why tertiary haloalkane, okay, unlikely to undergo SN2, while primary sangat suka. Okay, so dekat sini dia kata tertiary alkyl halides are more hindered than secondary alkyl halides and secondary alkyl halides are more hindered than primary alkyl halides. Hindered maksudnya apa? Maksudnya halangan, terhalang. Okay, jadi tertiary haloalkane ni untuk nucleophile undergo untuk buat backside attack ada banyak halangan. Halangan apa? Halangan alkyl group. Compared to primary haloalkane, halangan dia cuma satu saja. So it is easy for nucleophile to attack the partially positive carbon. Okay, so to get a clear view of what I have said just now, okay, now we're going to discuss about steric hindrance. Kan daripada tadi, I keep on mentioning about bulky alkyl group. Okay, bulky besar. Okay, macam mana bulky alkyl group ni boleh menyebabkan SN2 mechanism tak berlaku pada tertiary haloalkane. Okay, so in other words, lagi besar kita punya alkyl group, lagi susah SN2 mechanism akan berlaku. Okay, because nucleophile tak boleh buat backside attack. Okay, so steric hindrance. So steric hindrance is caused by bulky alkyl groups, okay, that makes nucleophilic attack from the backside more difficult and they slow the rate of reaction. Okay, so first and foremost, you need to understand the definition of steric hindrance. So hindrance dekat sini adalah halangan. Okay, sorry. Okay, pardon me. Halangan. Okay, and then steric dekat sini, steric ini just to show yang size. Okay, untuk tunjukkan size yang selalunya kita akan refer kepada size yang besar. Okay, halangan disebabkan size yang besar. Okay, so for example dekat sini, okay, so if it's this one, okay, kalau saya lukis dia punya structure in 3D structure, okay, molecular formula dia, katakan kat sini Cl, so CH3, okay, CH3, CH3, okay, even though it has 3 alkyl group, okay, tapi dia masih lagi boleh undergo SN2 mechanism, nucleophile. Okay, nucleophile dekat sini, okay, masih lagi boleh buat backside attack. Okay, dia boleh buat backside attack. Okay, so apa dekat sini? Okay, so for example, alkyl group dekat sini CH3 saja. So, if the alkyl group is small, okay, macam dekat sini, nucleophile attack is possible or easy. Sebab apa? Ada ruang. Okay, so bila kita susun dalam bentuk tetrahedral, so ada lagi ruang warna hitam. Hitamnya adalah carbon. Okay, there are still some space for nucleophilic attack. But if let's say I have this structure, okay, kalau saya nak lukis structure ni, okay, structure ni akan jadi macam ni. So C, Cl, okay, C, CH3, CH3, CH3. Okay, lepas tu dekat sini, okay, kat sini, kejap, sorry, terbalik. Okay, C, lepas tu dekat sini C lagi, C, okay, sini lagi C. Okay, meaning in other words, semua ni CH3 lah sebenarnya. Okay, all of these are CH3. So if you look over here, okay, nucleophile tak jumpa jalan. Dekat mana dia nak attack this partially positive carbon. Okay, so backside attack cannot occur for this one. Okay, takkan berlaku backside attack kat sini. So, kat sini, if all of this is alkyl group. So, yang ni yang kita maksudkan sebagai bulky alkyl group. Okay, yang mana alkyl group dia dekat sini, bulky alkyl group is this part. Okay, yang mana alkyl group dia terlampau besar. So, when the alkyl group is too big, it will give us a steric hindrance. So, halangan disebabkan size yang sangat besar. Halangan terhadap apa? Halangan terhadap nucleophilic attack, nucleophile attack. So, nucleophile tak boleh attack daripada backside. Okay, because of this steric hindrance, because of the big bulky alkyl group. Now, let's look at an example. So, give the SN2 mechanism for the formation of the product in the following reaction. Okay, so dekat sini kalau saya nak lukis balik, saya punya haloalkane. Okay, so CBr bond. Okay, so this carbon, this particular carbon is bonded to one hydrogen. Okay, and then it's bonded to a methyl group. And then it is bonded to another ethyl group dekat sini. Okay, so we have over here, okay, a secondary haloalkane. Okay, jadi secondary haloalkane, like I mentioned before, dia boleh jadi SN1, dia boleh jadi SN2. SN2. But this question clearly kata dia adalah SN2 mechanism. Okay. Satu lagi sebab kenapa boleh berlaku SN2 mechanism dekat sini, because okay, methyl and ethyl is considered small alkyl group. Okay, so maksudnya dia tak cukup besar, it's not a bulky alkyl group. So there is still some space for the nucleophile to do a backside attack. Okay, sebab lagi satu tadi kita ada satu hidrogen dekat sini. Okay, so it is possible to do a backside attack. Okay, jadi nucleophile kita dekat sini adalah hydroxyl group. So now let's take a look at the mechanism step by step. Okay, soalan kita tadi. So now let's start drawing our SN2 mechanism. Okay, so seperti yang telah dibincangkan, so bila kita ada SN2 mechanism dekat sini, okay, jadi kita mesti ada, okay, apa yang kita kena ada adalah, okay, we must have a one step reaction. Okay, yang mana kita punya rate determining step, the slow step must involve our haloalkane and then our nucleophile over here. Okay, jadi kita akan start dengan lukis dulu kita punya haloalkane. Okay, so macam yang kita dah lukis tadi, the haloalkane. Okay, so draw C. Okay, so let me move it over here. Okay, a bit. So C. Okay, so Br. Okay, so I put the hydrogen up here. Okay, so dekat sini. CH3 and then another one over here, CH2, CH3. Okay, so like I mentioned before, you need to draw your haloalkane, okay, in a 3D structure. Okay, sama ada awak nak buat dua dekat bawah macam ni ataupun dua dekat atas. Okay, terpulanglah ikut awak. Okay, so kita punya nucleophile, so OH minus dekat sini. Okay, mesti lukis dengan keadaan yang betul. Okay, kemudian okay, apa yang akan berlaku? So you know carbon is partially positive, bromine is partially negative. So carbon dekat sini, this carbon is our electrophilic site. So the nucleophile akan attack. Okay, so backside attack dekat sini. Okay, so ada ruang, so dia akan lakukan backside attack, and then dekat sini, okay, the carbon bromine bond akan start break. Okay, so you show an arrow over here, dan pada arrow mesti tulis slow step. Okay, jadi untuk kita punya transition state. Okay, so the transition state start by drawing carbon. Okay, and then 1, 2, 3. Okay, ini untuk apa? This is for the original haloalkane structure. Okay, jadi hydrogen dekat sini CH2, CH3, here is CH3. Okay, kemudian yang dekat sini carbon bromine bond, so awak akan lukis dia ada putus-putus macam ni. So bromine, carbon OH bond, garis putus-putus juga, OH, like that. Okay, and then you going to label this is as partially negative, bromine pun sebagai partially negative, dan jangan lupa mesti ada square bracket. Okay, dan mesti ada transition state symbol dekat sini. Okay, jadi tak perlu tulislah dekat sini, bawah ni tak perlu tulis transition state, but you need to have this bond. Okay, so pada transition state takkan ada apa-apa bond dekat takkan ada apa-apa arrow. Jadi kita terus move on. Okay, maafkan saya. Okay, we're going to proceed with the last step. Okay, so fast step dekat sini. Okay, so if let's say awak punya kertas dalam exam tak muat, letak arrow dia ke bawah. Kalau tak muat ke kanan, so draw the arrow downwards. So saya muat, so saya letak dia ke kanan lah. Okay, so dekat sini fast step, apa yang akan berlaku? Okay, so this carbon hydrogen bond akan break and the structure will be inverted. Jadi nak start lukis macam mana? Okay, lukis rangka dulu carbon. Okay, 1. So yang atas ni dia akan ke atas sini. Okay, so here will be your hydrogen. Okay, kemudian lagi dua structure. Okay, so dekat sini satu. Okay, maafkan saya. Okay, let me draw this better. Okay, hydrogen. Okay. So, dekat sini CH2, CH3, CH3. Okay. Okay, and then kita dah form OH bond dekat sini. Okay, so dah dapatlah kita punya substituted haloalkane tadi. So, haloalkane, the halogen group dah substituted by the nucleophile. Dan jangan lupa kita dah remove bromine tadi, so dia akan jadi Br-. Okay. So macam ni lah yang awak akan buat. So a one step reaction yang mana nucleophile akan buat backside attack kepada kita punya haloalkane, and the haloalkane you need to draw in a tetrahedral shape. Okay, dan dia akan tunjukkan dekat sini inverted structure. Okay, inverted lah. Okay, it will be like this.